Hello and welcome to Algebra 2A Credit 4. This is what we went over on the Monday's class, and I'll be doing a separate video to go over what we went over on Wednesday's class. So one of the things we looked over is how division is different from multiplication. And I had students pair up, and they talked about what they noticed. So as you can see here, we are dividing fractions versus here we are multiplying fractions. And what are just some things you notice? Well, one of the things students notice is that multiplication and division are similar, but they're not the same. So whereas they noticed that dividing did change to multiplication, and that the second fraction essentially flipped over, or was taken the reciprocal of. So when they divide fractions, they learn that it's kind of like multiplying, but they do have to do two extra steps, which is to change dividing into multiplying, and to switch around their second fraction. So if that was, like, let's say 1 over 2, that would change to 2 over 1. So that's one of the things they noticed. With that being said, they applied that to rational expressions. So here they were given this. It's fully factored, so we started off kind of easy, and one of the questions was which fraction will change. So they noticed that the second fraction will actually change. So that changes to multiplying, and instead of x minus 2 being in the numerator's position, it will be in the denominator's position. Notice how this is just copied down. Alright, and they kind of look to see what terms canceled out. Now for them, they noticed that x minus 2 and x minus 2 will cancel out, and x minus 10 and x minus 10 will cancel out as well. And what they found to be left over was 6 on the numerator's position and x minus 1 in the denominator's position. Continuing on, I wanted them to practice, how do I factor? That was the biggest thing for a lot of students. So one of the things we do want to factor, I'm going to put a 1 underneath this, we have fractions, is whether we factor using the greatest common factor for this one, 2x plus 6, or the x in the x box that we've been using. So for this one, I noticed that they do have something in common, so I could take a 2 out, and that would be x plus 3. And the reason I'm using greatest common factor is because the terms have something in common. So that's why we factor using greatest common factor. So that would be 2x plus 3 over 1. Now where this one is, they definitely have an x in common, and then I think they also have probably a 14 in common as well. So that'd be 14x, and that would be x, because 14 divided by 14 is 1, and that would just be an x left over, and I think this would be plus 3, so that would be 14x parentheses x plus 3. So that's the factored form. Now they do have to flip this over so that 14x parentheses x plus 3 would actually go on the bottom, because we have to flip the second fraction, remember? And they do notice that the x plus 3's kind of cancel out. That 2 and that 14 kind of reduce. 2 goes into 2 once, 14 goes into 2 7 times. So they're left with 10 on top, and then 7, just 7 on the bottom. Probably should move that 7 over, but you get the idea. Oh, and x, because x didn't go anywhere. So we still have an x on the bottom, 7, and 10. Now just so you know, you're like, where's that 1? Well, 1 times 10 is just 10. 1 times 7 is just 7. Alright, continuing on. So they had them factor, you know, whether they were going to find the GCF or using big X and X box. So with this one, they do have something in common. So they do have something in common. In fact, I believe they have a 9 in common. So we could take a 9 out, and that would be 3x plus 1. So that would be 9, 3x plus 1. And then they can factor this out. The reason there's 1, 2, 3 terms, so that already signals me that we might be using the X and X box because there are 3 terms. Also, they don't really have anything in common, which is kind of sad, but you know, we could factor that out. And then students factored, they factored, I might need to write these one on top of the other, so my bad. But that would be, I believe, 3x and x, and that would be minus 3 and plus 1. So that would be 3x plus 1 and x minus 3. Alright, and then I would flip these over so that 10 wouldn't be in the denominator's place anymore, it would be on the top. And that would be 3x plus 1 and x minus 3. If you're not sure how to factor that, you know, you can always ask for help on how we factored that out. We've been doing this for a while, so we should know how to factor by now. These would cancel out. That would cancel out, and I'd be left with 9 over x minus 3. Alright, continuing right along to this problem. So I copied the factors. We're not making you, by the way, redo the problem. So that wasn't the point of this number 8. A lot of students thought they had to redo the problem. They do not. All we're going over is excluded values. Remember, excluded values are what is a number that would make the denominator 0. And with that being said, that means that we're going to set each of the denominators equal to 0. So that means I'm going to set this equal, and that equal, and that equal to 0. And I'm going to figure out what x can't be, what x cannot be, to make the denominator 0. So if x was 1, that would make the denominator 0, so it can't be 1. And if x was positive 10, that would also make this denominator 0, so x can't be 10. And if x was positive 2, that would make the denominator 0. So that's what we were going over for number 8. Number 9, again, the excluded value is that denominator. That would make the denominator 0. So we're going to set each one of these equal to 0. And find out what x can't be. So that would be divided by 14, divided by 14. X equals, or can't be, 0. And then if I solve that out, x cannot be negative 3 either. So these two are excluded values. Okay. And last but not least on the worksheet, we also did number 10. Again, we're not redoing it. We're just finding out what excluded values, what x can't be, that would make the denominator equal to 0. So we set each one of these equal to 0, and we solved them out. So this one, if I add 3 to both sides, x cannot be 3, because that would make that denominator 0. And for this one, it's a two-stepper, so what's the opposite of multiplying? Dividing, that would be x cannot be fraction negative 1 over 3. Okay. Alright, so moving on to explain 2, dividing. So this is in your packet. It's not a worksheet, but this is in your packet. So I had students factor both the numerator and the denominator. And that would be, again, take some time, factor it out, but that we found these to be 2x plus 3 and x plus 3 and minus 1. And then we'll change that to multiplying. Flip these guys over. So that'd be x plus 3 times x minus 1 on top. And 2x plus 3 on the bottom. This one did not flip, so I'm just going to copy this down. And I'll notice these two will cancel out, and I'm left with, on top, x plus 11 and x minus 1. And 4 times 2 is 8 with an x on the bottom. That's my quotient. Awesome. The next thing we did was we tried to find our excluded values. Let me just change this to a highlighter so that way you can see what factors are we going to set equal to 0 to find out what my excluded values are. So these factors we will set equal to 0. I'm going to do this on this side of the page. So that would be 4x cannot equal 0, x plus 3 cannot equal 0, and x minus 1 cannot equal 0. That's a big no-no. Alright, so if I solve each one of these out, x cannot be 0. For this one, x cannot be negative 3. And for this one, x cannot be positive 1. So there's all the things that x can't be. Alright, moving right along to number 5. I had students factor this, this, and this out. Pause if you need to, just to figure out what those factors would be. But I'm going to move right along. That would be x minus 7. Again, dividing, that would be 5x, x minus 8. And then for these factors, that would be x, and that would be, I believe, negative 7, negative 8 for those factors there. Change that to multiplying. The first fraction is not going to change at all, but this one will flip, so I'll kind of write the denominator on top now and the numerator on the bottom. See what cancels out. X minus 7, x minus 8, 5 can go into 24 times, and I'm left with 4 on top, and I believe x to the second power on the bottom. Okay, so there's my quotient. The next thing I'm going to do is I'm going to highlight the values for, so I can find my excluded values. Alright, here we go. So I'm going to go ahead and set each one of these equal. X cannot be equal to 0. Well, there's an excluded value there. X minus 7 cannot be equal to 0. X minus 8 could not be equal to 0. And I'm not going to redo, because it's the same one. I'm not going to redo the same problem again, but x minus 2, what's the opposite of an adding? Oh, I'm sorry, subtracting 2. I kind of gave it away. Right. X cannot be 7. And so for this one, what could x not be equal to? Positive 8. So these are all of our excluded values, because they would make the denominator 0, and that is a big no. Just so you know, that's how you kind of keep it. If the 0 is in the denominator place. No, it can't happen. It's not allowed. Okay? It's a little memory tool to kind of help you remember. Alright, moving right along to our checkpoint. We only have about 2 problems left, but I think I'm just about out of time for this video here, so I'll do 9.2, numbers 4 and 8, and show you your homework that we did in class. Alright, see me on the next video.